Hello! This video will explain the concept of pulse width modulation, or PWM, when applied to LED brightness control using Python with Raspberry Pi. Using PWM is a common method to control brightness of LEDs, whether they are small, what we use on a breadboard, or in standard household lighting. Pulse width modulation relies on rapidly cycled DC power, resulting in a square wave. The brightness of the LED is proportional to the size of the pulses, otherwise known as the duty cycle. The wider the PWM pulse, the brighter the LED. Let me demonstrate how it works with the Raspberry Pi. GPIO0 library has the PWM LED class suitable for that application. This class has a pulse method which will smoothly vary the LED brightness. It also has a value property which takes a floating point number between 0 and 1, allowing to set the LED brightness from off to fully on respectively. I have 3 LEDs on my breadboard, and each of them uses the pulse function in a different way. The left side LED uses pulse with the default timings, 1 second to ramp up and 1 second to wind down. The middle LED starts with full brightness and then slowly fades away over a period of 2 seconds, while the right side LED comes on to full brightness over 2 seconds and then dims over 2 seconds. Have a look at this in action. Although this is software-based PWM, which makes it subject to some amount of jitter, this actually works quite well. Any flickering that you may see right now is just video recording artifacts, as the LEDs pulse at 100 Hz, while I record this at 24 frames per second, so this does not align perfectly. In real life, that actually looks pretty good. The pulse method is useful if you want to have this effect. You can control the timings, and it runs in the background as a separate thread. There is no need to have your own loops, and the brightness levels change very smoothly. Setting the PWM LED value property is another way to control the LED brightness. The value property number refers to the PWM duty cycle. My example sets the duty cycle at 3 different levels, from 100 on the left to 25% on the right. If you really look at them, the brightness is not that different. That's because LED brightness follows a logarithmic curve when using PWM power. This makes the value property difficult to use, as it is hard to predict what the relative brightness will be for a given duty cycle. This is particularly problematic when attempting to have gradual changes the way the pulse method works. Let me illustrate that using a spreadsheet. The logarithmic LED characteristic results in brightness levels changing rapidly on the low